My name is Stefan Carrera. I am the Education Manager here at STLE, and I will be somewhat hosting this webinar. I have a few things to go over before I turn things over to our two speakers. And sorry, I got distracted by the message here. But NLGI's new high performance multi-use HPM grease specifications, development details. Our two speakers today are JP Kirprick and Chuck Coe. They are members here at STLE as well as NLGI, and we've got a lot of great information to share with us. But before we go to the good stuff, we have a little bit of admin things I need to go over. So if at any point you're having some sort of audio issues or things like that, please give us a call. Use that number on the screen there. That's direct line to myself, and I will do my best to help kind of walk you through and see if we can't figure out your audio issues. Keep in mind, this presentation is also being recorded, and that recording will be available to everyone in attendance and everyone else who signed up who couldn't make it tomorrow. So look for that in your emails tomorrow. I'll be sending that out. And if you haven't noticed yet, as a attendee, you are in listen-only mode. You are unable to use your microphone, but we do have a time for Q&A, and we do encourage participation. So if you can actually locate on the right-hand side of your WebEx window, you should see a Q&A box. It might be collapsed, so you're going to want to open that up, and you'll see where you can enter in your questions. So at any time throughout the presentation, if you have a question about the information being shared, please put it in that chat, and we'll have a time for Q&A at the end with Chuck and Joe. And now I'm going to do a little bit of a short intro on our two speakers before I turn things fully over to them. So our first speaker today is Joe Keperick. Joe is the Senior R&D Advisor for Greases at Afton Chemical. Joe has been recognized as a Certified Lubricating Grease Specialist by NLGI. He's a member of STLE and chair of the joint NLGI-ELGI Working Group on Grease Particle Evaluation, and the chair of Section G01 Chemical and Laboratory Tests for ASTM, and is currently serving as past president advisory on the NLGI Board of Directors. So you see Joe's got a lot of experience, great background in the topics, and we're excited to hear from him. Our next speaker is Chuck Coe. And Chuck Coe is the president of Grease Technology Solutions, LLC, and the past president of NLGI. Chuck holds a BS in Chemical Engineering from the Pennsylvania State University, along with NLGI CLGS and STLE CLS professional certifications. Chuck was hired in 2019 by NLGI to serve as a technical expert during the high-performance multi-use grease development process. His passion and commitment for this project, combined with his expertise, has helped NLGI propel this new certification. And Chuck is also on the STLE Education Committee. So I work with him a lot. Chuck's a great guy, another person full of knowledge and experience that he's ready to share with us today. So I'm going to turn things over to Joe, and he's going to take things off. Well, Joe, passing you the presenter.
All right. Thank you, Stefan. All right. I think we're good here.
Yep.
All right. Fantastic. Thank you very much, Stefan, and thanks again to everyone for calling in. Good morning, and I see good afternoon to at least a couple of people from the European side, maybe elsewhere. Chuck and I are going to try and basically walk you through the updated details of where we're at with HPM and the new high-performance multi-use grease specification. I see quite a few of you that have logged on from previous discussions. I think some of you are aware of some of what we're working on, and some of you hopefully are more informed than others, but we're trying to get the word out and make sure that everybody in the industry understands what we're doing, why we're doing it, and how we're doing it. So today, between Chuck and I, we're going to kind of cover the history, go into the details of the actual specification, which has now been approved by the NLGI board. We're going to do just kind of a comparison because we now have a whole suite of specifications through NLGI. So we're going to compare it to the GCLB specification, how that lines up. Talk about some special applications, compatibility issues that might arise, questions around that. And then more kind of the nuts and bolts of the trademarking, licensing, certification, audit process. We have some details we can share with you today, some that are still being worked on. And then just a little bit about future plans for the spec and where we would go from here and how you might be able to help us. And then we'll have time, hopefully, for some questions from you if we haven't covered everything that you'd like us to cover. So stay tuned. Feel free to use that Q&A tab along the way, and we will get to the questions at the end, though. So we're not going to try and break off in between here. It's too much technology for the two of us. All right. So if we jump in here, of course, it never actually starts when you want it to when you're live. All right. So this is just kind of a quick background of where we've come from and where we're going. And this is, I went into more detail in some of the previous discussions. But at our last, during Technical Week in August, during our panel discussion, I did a little more digging in this. And it turns out there were initial discussions back in 1933 about a request for guidelines for specifications to help guide users. And that was some discussions between SAE and what shortly formed as NLGI in the 30s. So where the formal discussion we talk about typically goes back to 1966, and the fact that this kind of group discussion between NLGI, ASTM, and SAE, the Society of Automotive Engineers, got together to kind of try and develop this guidance for the industry, specifically for the automotive industry and for automotive service greases. And 23 years later, they had a set of specifications around chassis and wheel bearing greases. Now, to their credit, they had to develop, I think, 4, 5, 6 different tests, new tests that didn't exist to be able to do that. And that was the bulk of that time there. And I think some of you are more familiar with some of those tests within GCLB that it maybe have some reproducibility issues or we would like to improve upon to more modernize. And some of those discussions started in around 2012, more formal discussions around how to fix some of those tests. But in 2015 really was when NLGI kind of recognized, hey, you know, we really do need to talk about upgrading GCLB. It's been some 25 years, and we really need to kind of think about where we go forward with this. We've set up a formal working group to talk about that. We recognize through that GCLB is still alive and well. A lot of people using it, over 300 people certified against GCLB today. It's 300 formulations. So we didn't want to get rid of GCLB. And when we actually got into talking with end users and stakeholders, we realized that what we needed was a new set of specifications that were kind of aimed at more performance that in some cases, GCLB is being used for. GCLB is one of the few recognized certified certifications out there. But as an automotive wheel bearing chassis grease, it's really not being used much for that purpose. It's being used to point at as, hey, this is a good grease. You can, you know, it's certified by NLGI. You can use it in this application. And in some cases, it's actually called out in specifications. So we don't want to get rid of GCLB. But we do want to develop a new set of specifications that is in parallel to that and is more driven towards different specific performance areas that we think are needed. So GCLB not going away, but adding to that is this new high-performance multi-use specification. So to kind of put the framework around it and to talk a little bit about the fact that this is not just me and Chuck. This is a bunch of people within NLGI, a lot of the membership, the board, the executive committee, but also some outside parties. The Center for Quality Assurance we brought into the loop here almost over a year ago now to help us push this through. So this is the timeline is on the right, kind of how we worked through this. Some of you I know were involved in our workshop in March that ended up being a virtual workshop, but a workshop to help discuss what should be in the specification, what some of those tests should look like, what some of the limits should look like. And I think we did a pretty decent job of doing breakout groups through WebEx. But we managed, I think the idea here is to show you that there's a lot of involvement with a lot of governance throughout this entire process. So at the end of the day, there's a steering committee, grease specification steering committee that I'll talk a little bit more about in a second. But they did the bulk of this work along with Chuck and CQA in developing and finalizing the specification. It also had to get approved through the NLGI's executive committee and ultimately then the NLGI board of directors. And the board did finally sign off on this spec this month. So this is good timing to kind of bring this in front of you and show you the final spec. And we are now in the October to December box up near the top there. And basically, this is part of kind of helping us publicize what we're doing, publicizing the specification and talking to people who hopefully are interested in using it. And in January, we are still on target to launch the formal use of the HPM grease specification on products. So what is HPM? High performance multi-use. And these are the series of grease specifications around that. The overall goal here, as I said, was just it's kind of to define new specification categories that are going to have higher performance for specific areas, and we think a broader usefulness then to the market. So it's not replacing GCLB. But the idea here is to define the greases that meet the core HPM specification. So that is, there is a high-purpose multi-use specification that is what we consider kind of the core spec. But your grease could have just an HPM label on it that says this is good for, it's a good high-performance grease for multi-use applications. And then we've defined further subcategories where you might want to further enhance the formulation, or you might have a further need for enhanced resistance to water, for instance, or high load carrying capacity, saltwater corrosion resistance, low temperature performance. So those are the four that we are ready to roll out right now. During those discussions, we've had a lot of conversation around high temperature and or long life. Those may end up being two separate specifications. They may end up being almost additional parallel specifications in as we go forward, but those are under discussion for future use. The four top ones there, along with the HPM core specification, are what we are ready to roll out this year. And just to emphasize, I'm sure Chuck will talk more about this as we get into it, but each of the enhanced subcategories must also meet the core specification as spelled out. So it's going to have that multi-use grease performance ability and then additional water resistance or additional corrosion resistance, et cetera. All right, so how did we kind of go about this? And this is very high level, and I think Chuck will talk more specifics and bring up a couple of case examples as we go through. But our strategy as a whole was really to kind of build these specifications around performance. And that's really in parallel to what GCLB did. So GCLB was aimed at wheel bearing greases and chassis greases for automotive use. And the tests that were identified around that were set around performance of the grease to meet use in those areas, right? So GCLB has somewhat expanded to almost be multi-use in some cases, but originally was set up for specific performance under identified conditions. And that was what we wanted to do here. With those identified conditions kind of evolving as we talk to all the stakeholders. And that was the second part of this, is to make sure that we got feedback from as many stakeholders as we could. We talked about this in conferences. We advertised, we sent out communications, we had webinars, we had individual interviews with multiple end users, stakeholders, marketers, all around the world. And we got as much feedback as we could from them. And then the cross-functional steering committee was formed from key stakeholders of NLGI members. So marketers and end users are all part of this process. Additive suppliers and instrument manufacturers, everybody has been represented here to kind of, how do we move this forward and what really belongs in here? What format should this specification take? What's the best use for us as an industry? And that's how we arrived at the kind of the key areas we wanted to focus on to start with. And some of the key areas that we wanted to be in here, but we recognized might need new tests developed or might need more discussion. So that steering committee has been key in kind of paring this down, but also continuing the discussions and making sure that what we end up with is useful for the industry as a whole. And those performance limits that Chuck will talk about shortly, the whole idea here is that they be challenging but still achievable. So it's a multi-use, but it's high performance. So it needs to make sure that this is still achievable with greases out there today, but is of use to the industry if you want a high-performance multi-use grease. So that's a kind of a balance there, and that doesn't mean the same thing to everybody. So that's the steering committee has been key in kind of making sure that there's at least consensus within that group as to what should be in here and where the limits should be set. And then another part of this is also to strengthen the certification and the audit process to make sure that the quality is there when an end user picks a grease that's meant to have these performance, this kind of performance, that it actually does. And that helps you if you have the mark on your grease, and it helps the end user if he expects a certain amount of performance from that grease. The benefits that we see then is providing these specifications really are tools for grease marketers to have a better communication with their customers, right? So to be able to talk to the customer about what this grease can do, what performance there is in there, how your grease is going to help your customer meet the needs that he has. Educating the end users, this is, I think, an area that we need to do better in as NLGI, but educating the end user about the capability of the grease, not just, oh, it's got an NLGI tag on it, therefore I guess it's better than the one that doesn't, but really talking more about and educating that end user about what the capability is of the grease and helping him to pick something that's best for his needs, along, usually with as part of a communication with the marketers. So overall, unified guidance then that's based on the performance of the grease, and that unified guidance coming from NLGI and NLGI experts within these areas to define that and to help kind of set that bar out there for the industry. And at the end of the day, then, increased product quality because of the higher level of certification and audit testing that will be part of this process as well. So that's kind of big picture strategy and the benefits that we see of this, the new grease specifications that we're rolling out. Now, a little bit more detail then into kind of the philosophy, if you will, of the discussions. And this did not, come at the first meeting. This was kind of developed through many conversations with the steering committee, with stakeholders, and within the board. The final specifications, as I mentioned earlier, have been approved by the board, but that's, it took a long ways to get to that point. And just to kind of talk a little bit more about that piece of it, this specification or these specifications are performance-based. So there's a range of NLGI grades. It's from number 1 to number 3 could be used for this. We're not specifying you have to have a certain grade, just as GCLB does not. And performance is the key here. So you don't, GCLB doesn't specify what kind of a thickener or what kind of a base oil or anything more about it other than it needs to meet the performance needs for a wheel bearing or for the chassis in an automotive application. So for the multi-use greases, we want to know, is the grease capable of supporting a high load, if that's what the grease is that you're picking. You have a need for preventing corrosion. Will that grease do it? Is it structurally stable enough for what you're looking for? So it's all about the performance. It does not specify a type of thickener, a base oil, an additive, or any other raw material. Nothing. If you can make a grease that meets the specification and has the performance that's needed, that's the key. So the end user then gets assured that the performance that they want is built into that grease. They don't have to know the difference or the advantages of using a polyurea or a calcium sulfonate, or using a synthetic base oil versus a mineral oil, or having molybdisulfide or not. So the rest of those things are a conversation that can be had, but the end user shouldn't have to know that to be assured of the performance of the grease. And that really allows then for that cost-performance balance to be looked at by individual marketers, manufacturers, formulators to, can we make a grease that makes sense for us, for our customers, to meet these performance levels? And that's then allows for that optimization from that standpoint. So it doesn't prevent the grease marketer, though, from highlighting other areas. So as a grease marketer, you can highlight the thickener that you're using. You can highlight the fact you're using a synthetic base oil, or that you have a high dropping point, or that you have molybdisulfide or other specific chemistries in there that you think might help the conversation with your customer. So that additional education, that additional communication is still there. This doesn't take away from it. This just kind of gives you a building block to help you start that conversation and to help you. We've started at this level of performance right here to start with. Now, what else do you want to talk to me about? Your specific application, your needs, or what's involved in your formulation or your grease. Okay, so with that, I'm going to pass over to Chuck, who is going to take over as soon as I pass him the ball. And he's going to talk more then about the specification itself and more of the details of that to kind of fill you in on where we're at today. I think some of you probably will have already seen some of this, but these are now, as I said, approved by the board, and these are kind of the finalized limits that you may or may not have seen so far. Chuck?
Can you see my screen okay?
Yes.
Okay. Thanks, Joe. That's a great introduction. Now I'm going to get into the specifications themselves, and I'm going to start by talking a little bit about how we chose the tests, the limits, the conditions of those tests in our specifications. It was a very lengthy and I think thorough and detailed process. So the first thing we did, let me get this over here. Okay. The first way that the tests were chosen and the limits was by the initial work. It had come about through the work group since 2015, but more focused after our national meeting in June of 2019, when the NLGI board basically said, let's develop a new specification. We're going to stop focusing on trying to fix GCLB with its issues. So let's build a new specification. Well, starting point, for the most part, was based on GCLB, which is ASTM D4950, and a number of other sources of data, public sources, industry marketing specifications and claims, and so forth. So that was kind of the starting point, and those tests and limits were really responsible for quite a bit of the original draft specification. Then, as Joe mentioned, we did a lot of talking to end users, GCLB certification holders, OEMs, and other stakeholders. And this process was conducted from, I came on board the project in September, and starting in October with Mike Kunzelman from CQA, we conducted numerous interviews through the fourth quarter of last year and the first quarter of this year with all those interested parties. And that was used to adjust limits, maybe delete or add tests. We got quite a bit of good feedback from that. Then the next item that was a significant contributor to fine-tuning the draft specifications was the virtual feedback in March, which Joe mentioned. We had 45 participants, stakeholders from the Greece community. It was we got a lot of feedback. We had breakout groups. This was the first time we tried to do anything like this in a virtual sense. So we had people in a general session, then everybody broke off and dialed into their breakout groups, and there were captains of the breakout groups that captured all the feedback, and it was quite a process of going back and forth. And then the steering committee looked at all that data, and working with the table captains, we distilled the data, evaluated it, finally used it to make further adjustments in the limits to gain better consensus. And then there was a steering committee internal data review. If we still had some open issues, which we did after the virtual workshop, then the steering committee went back into their own companies to look at data on their own products or their own products they had experience with, to see whether there was a way to develop consensus around limits for the tests where we still had outstanding issues. I'm going to give examples of these different processes that we went through, the iterative steps that we went through to develop and refine the specification. So I'll give examples as I go through the spec. And then the final step, there were still a few tests where we simply did not have enough data, publicly available or otherwise, in order to feel 100% comfortable about the test conditions and limits we were establishing. So we developed a program to do validation testing. And in this, there was where we had stakeholders, primarily from the steering committee, who basically went into their company's product portfolios and looked at their data, in some cases ran some additional test data in order to answer some of the questions about limits on certain tests, to see if a product they had that they said probably would meet, let's say, HPM plus high load HL, and they'd go back and look at the data on their products that they thought would meet those limits, and to see if they were capable of meeting the limits that we had established. So that was for really some certain key tests, and that was the final part of the process in order to get to the final spec. All right, so now I'm going to talk about the specs. I've got 2 slides on high performance multi-use spec, and then the core spec. And then I'm going to talk about each of the enhanced performance tags, as we call them, the high load, the water resistance, the corrosion resistance, and the low temperature. Okay, hopefully this is not an eye chart. Tried very hard to get a good bit of data on the slide. So I'm going to run through this data and make some comments, and also give you some examples of which part of the limit selection process was used. So first thing is the cone penetration. And in this case, we allowed it to be the same range as we have with GCLB, as Joe had mentioned, allows a number 1 grade through a number 3 grade. And interestingly enough, this was something that evolved, because originally we had 3 different sets of limits you had to fall into, the 1 grade, 2 grade, or 3 grade. And then after some feedback and discussion, it was pretty quickly decided that this would eliminate those in-between grades, which are sometimes claimed as, say, 1.5 grade. So we said, let's just open it up to the entire range and not specify particular NLGI grades at all. So that's the same as the GCLB. So the next one is the extended worker cone penetration for 100,000 strokes. And this test had probably some of the most discussion through the entire process. It's a common test. It's not in GCLB, but it's in many industry specs. But these are challenging limits, there's no question. And in this process in particular, what became evident is that not all thickeners perform as well as other thickeners in this kind of a shear stability test. So the concern was that we were specifying a test and limits that were going to disallow certain thickeners. And the intention of this specification, as Joe mentioned, is to ensure a high level of performance and not to specify anything about the raw materials, whether they could or could not be used. So the greases of concern in this area, in particular, were polyurea and aluminum complex. So we did some digging, had a lot of help, looked at data that some of the steering committee developed, looked at some commercially available data and claims, and discovered that in fact you can meet these limits with polyurea greases. They certainly don't all meet them. And you can meet these limits with aluminum complex greases. So based on that, we decided we were going to stick with our philosophy of being chemistry neutral, and we kept these specifications as tight as they are. And they are challenging. The next test is elastomer compatibility. This is another one that had quite a bit of discussion. They won't all take this long to talk about it. Some were relatively easy to agree upon. The elastomer compatibility test in GCLB is D4289. This is the same test, the same methodology, but we've changed the conditions and we have changed the elastomer. NBR is one of the elastomers in the GCLB, but I'm not the expert and I'm not going to talk all about that, but there was a lot of work being done that had been done and is still being done to specify the proper type of NBR elastomer and to find, basically to find a source or multiple sources so that this is not an issue of getting the rubber samples. So this one still has some work ongoing, but I'll say that this is one of the examples where road testing, the validation testing that some people were able to do on pretty similar elastomer look good so far. So we think that the test conditions and limits will be good. So I'll move on from that. That's one of our remaining somewhat open items. And the way we will deal with that, if we do not have the elastomer fully specified and available by the time the spec goes live in January or during the process of people submitting data and samples for approval, we will allow people to get approved for HPM without meeting an elastomer spec. And we will call this sort of a temporary, I forget our words that we're going to use. I know. So anyway, we're going to allow the grease to be certified without meeting this spec. Once we get this test fully online with the elastomer specified and available, we will then require it for all future certifications. We have another test, fretting wear, which I'll talk about. It's the same kind of thing. The next one's oxidation stability. No big deal on this, very common test, very common specification, good agreement quite easily on that. The next test is water washout. Another pretty standard test, another pretty standard limit. This is based on, this is a spec, a test. It was based off of the GC specifications, but it is a more severe limit. GC specifies 15 maximum, and we've got 10% maximum for the HPM. Again, we're trying to establish a higher level of performance. Okay, and then the last test on this slide is low temperature torque of ball bearing greases. This is another one that underwent a good bit of change. Initially, the first draft of the specification had this test at -40°C. The GCLB spec has a low temperature torque at minus 40 C, but it's a tapered roller bearing test, different method. And this being a test method that we thought was more appropriate for industrial greases. And this is one where the interview process really had a bearing on the final spec. Originally, we said minus 40, and then when we really got into discussions with end users and so forth, it became apparent that a high-performance multi-use grease does not need to perform this well at minus 40 C. It's not a low-temperature grease, it's a multi-use grease. So we ended up settling on minus 20 C for this test. And again, the validation testing so far looks very good on that. So we feel comfortable with that limit where we settled. Okay, let's move to slide 2 on high-performance multi-use grease. So oil separation from lubricating grease, E1742. This is exactly a test based on GC. It's a slightly tighter limit. GC specifies a maximum of 6%, and we reduced it to 5%. And we added another oil separation test, which is more severe. This is called the cone bleed test. And this one is at a high temperature, 100 C, whereas the other one is at essentially room temperature, but under a bit of pressure. So this method, we specified slightly higher maximum limits to recognize the difference in severity between the two tests. Then the next one is roll stability. This is not in GCLB. And what was interesting to note as we went through this process was there's nothing in GCLB that talks to mechanical stability of the grease, which is surprising. I don't know, maybe some of these tests weren't available at the time back in 1966 and so forth. In any case, we've got a few of them in HPM. So the first one is roll stability, standard test conditions, 2 hours at room temp, and the plus or minus 10% is a pretty common and well accepted limit, so there wasn't a lot of back and forth on that. Then the next two tests are the 4-ball tests. The first one being the wear test, E2266, and the next one being the EP test, or weld test, as it's sometimes called, the B2596. So this is one that there was a bit of back and forth, but we quickly settled on 0.6. It is, matter of fact, it is pretty much the same as GC, 0.6. LB has a 0.9 maximum. So 0.60 is where we settled without further ado. And then the EP spec, we initially had a 200 kilogram weld load. And this is one where the feedback from the interview process said, you know, a 200 weld load is not really very challenging at all. Doesn't tell you much of anything about that test. So we ended up revising that upwards to 250. And let me explain a little bit about the process. Since these interviews were mostly conducted by Mike Kunzelman and myself, we basically consolidate the feedback we got, and then we had monthly meetings of the steering committee, and we would present our findings and make suggestions on revisions to the spec. But the steering committee had to vote and approve on all of these. So the move, for instance, from 200 to 250 kilograms weld load was approved by the steering committee through that process. The next test is a standard rust test, E1743, with pass as a minimum, and that's the same as GCLB and the same as many industry specifications. And it's a pretty standard test. Then we decided to get a little bit more severe, and we added the MCOR rust test or corrosion test with distilled water. The difference being that this is a dynamic test compared to the D1743 that's a static test. So this was a new addition, and we quickly came to a comfort level with 0, 1. And what that means is you can have a corrosion rating on 2 bearings of a maximum of 0 on one of them and a maximum of 1 on the other. A 1-1 would not pass this. And then the next test is copper corrosion. And this, again, is a very common industry spec. and we added that, the 4048, and no problems or issues on the addition of that. Okay, now I'm going to go to the high performance multi-use grease spec plus water resistance. Okay, so water resistance, we have 3 tests there for water resistance. One is water washout, one is water spray off, and one is what we call the wet roll stability. It's roll stability in the presence of water. So let's talk about each of them for a second. The water washout test is, again, a very, very commonly used test in many industry specifications. It's in CLB, but we set a more severe limit. We set it at 5%, whereas the whereas the HPM spec itself is set at 10% max, and GCLB is 15. So we've ratcheted it down in 2 stages. HPM is more severe than GCLB, and HPM plus WR is yet another step more severe. Determining the resistance of grease to water spray. This is a test that is new. It's not part of GCLB. There was considerable discussion around the limits to set for this test. This is a test that's very important for like the steel industry and paper industry. In this test, water is impinged directly on a panel containing a thin film of grease, and it sprays off most of the grease in 10 minutes, 5 minutes rather. So a typical everyday grease you find in the market today would probably be around 90% spray off. Not very good. Greases for very high water spray applications like steel might have a 30% or lower maximum. So we were in quite a bit of discussion going back and forth, where there were those that favored very close to 30 and those that favored more moderation, because this is not intended to be a specialized grease for steel, for instance. So we settled on a sort of a compromise in the middle of 40, and that was agreed by consensus by the steering committee. And that seems to have been well received by the interviewees during the process as well. Now, the wet roll stability is a fairly new test altogether. I don't know the year it was developed, but you can see by the ASTM D8022, it's not an older test. So this one, there were those in the steering committee that had pretty good knowledge of the test and felt very comfortable with plus or minus 15%. And this is one of those tests that, quite honestly, we simply could not get enough data on it. So what we ended up doing was including this in our validation testing. And so far, the validation testing has shown that these are going to be good limits. A good high performance multi-use grease with water resistance can meet these limits. Okay, now we're going to talk about HPM plus CR, or corrosion resistance. Now we call it corrosion resistance. It has a nice ring to it. The reality is all these tests are about salt water or seawater or sodium chloride containing water. So it's really saltwater resistance that we're talking about with this spec. So we've got 3 tests here. 2 of them are the same method with different solutions. That's the D6138, which is the M-Core test again. If you recall, we have the M-Core test with distilled water as part of the HPM spec. But these are 2 solutions. One is 100% synthetic seawater, as defined in ASTM D665. And then the other is 1/2 normal solution of sodium chloride, which is about 3%. The other test at the top is basically the standard rust test that's part of HPM. It's just a pass-fail test, and it's a static test, but it's in this case, in the D5969, it's in 10% synthetic seawater. So that one we established as a pass minimum, new test, and more severe than the HPM, same test with distilled water. Going back to the M-Core test, These are examples of some tests that the limits were revised as a result of the interview process. We initially, these were revised more as a result, less of the interview process and more from the March workshop that we held. We had initially had a 1-1 max for the 100% synthetic seawater and a 2-2 max for the NaCl solution. And it was felt that to be very difficult to meet those limits consistently. So after much discussion, review of all the feedback from that workshop, we revised those limits slightly upward to a 1,2 for the 100% synthetic seawater and up to a 2,3 for the 1/2 normal sodium chloride solution. Okay, now we'll go to the HPM plus HL, high load. We've got quite a few more tests on this than some of the other ones. So we've got the first two are our favorite 4-ball tests, D2266 wear test and D2596 EP test. And the first, the wear test, we wanted to establish something that was more severe than the HPM. If you recall, the HPM upper limit is 0.60 millimeters. And so we dropped it to 0.050. And there was some concern about that, and I'll talk to that in a minute. And then the EP test, we initially had a 315 kilogram weld load set in the draft specs. And through the process of interviews, if we were going to move we quickly had decided to move the HPM from 200 to 250. So we just about as quickly decided to move the high load spec from 315 to 400. And there was a lot of discussion about 400 is not really a high load grease. Well, again, we're not trying to be a specialist grease for extreme loads, maybe for mining. I know there are specs out there that require 800 or 620 or whatever. We decided that doesn't make sense to go that high. Keep in mind, read it again, high performance multi-use grease plus high load. This is not a specialist high load grease. So that's how we settled on those two. Then we've added a new test here, which is an SRV test. And I'm going to talk about the two SRVs together. This is the extreme pressure test. There was quite a bit of data review and felt that 800 kilograms, newtons minimum would be the appropriate limits. And we established the conditions at procedure B at 80 degrees C. Quite a bit of data was available from Optimal and others. The main concern, there was a lot of discussion around this test and around the next SRV test that I'll talk about. The main concerns were, quite honestly, it's an expensive piece of equipment to purchase, and it's not as readily available in third-party test labs to have it run. And if it is, and it is, we found at least 5 laboratories that have the ability to run this test. I don't know where the pricing to have it run is going to settle out. It's a little bit all over the place right now. But it's not a cheap test to either buy the equipment or to have it run. But eventually we settled on that it was a good test and a test that establishes a different perspective on load carrying than the 4-ball EP test does. Then the next one is the fretting wear test. This is one that was developed for the GCLB spec. Remember, Joe was talking about 4 or 5 new tests that had to be developed in that 20-year process. Well, the fretting wear test is one that did. This test has a 10 milligrams maximum in the GCLB. We established this at a much tighter 5 milligrams maximum, but there are major problems with this test right now. There's the wording I was looking for before, provisional licensing. So what we will do with this right now until ASTM resolves the issues with having the bearings more properly specified and having consistent bearings available to run the test with. So we're going to use provisional licensing on this. We're keeping the test in. There was discussion around, well, let's take this test out since it's really not a good test right now and just go with the SRV. But there was very strong support to keep it in. People have a lot of experience with it. And if we can get back to having it run with the same or better precision as it used to be with good bearings, then it'll be adding a good piece of additional data to the SRV fretting test, which is the next one. And D7594 is the SRV fretting wear test. Same discussion as the other SRV test, cost and availability, but plenty of data available to set that limit. So we were happy with that. I just mentioned that the 0.5 maximum wear scar and that 4-ball was a bit of a concern. The concern was that if you formulate a grease to be HPM plus HL and meet that 400 kilogram weld load, it might be difficult to still meet that 0.50 wear scar. But we have done some validation testing with real greases and determined that that should not be a problem. Okay, let's talk about the low temperature tag. Interestingly enough, if you've seen any of the early work that was done on this project, and I mean early by back last summer and early last fall, there were 4 performance tags, enhanced performance tags, and the 4th one was not low temperature, it was long life, or maybe high temperature. We decided that long life spec was going to take a lot more work to get done because it's going to require development of new ASTM test methods. So that one's years out. So we eliminated that one. But during the interview process, people told us, well, where's your low temperature spec? So we put together a low temperature spec, and here it is. So what we've got here is 3 tests. We have, again, the low temperature torque ball bearing grease, but we go with a lower test temperature than HPM. HPM is -20, and here we go with -30. Not -40, we're still not trying to be an Arctic grease. We just want to be high performance multi-use plus better low temperature performance. And then we added grease mobility test. Right now, this is simply an old US Steel test method. It does not have ASTM precision statement. It needs standardization, and work is underway by myself and some others to help consolidate various companies' internal test methods into a common method that we can establish as an NLGI test method and run some round robin testing and establish reproducibility so that we can feel comfortable when we start auditing samples against this limit of 10 grams per minute. And then eventually we hope to push it through with ASTM. And then the last one is the flow pressure of grease according to a DIN test method. DIN is a German standardization institute. I may be saying that a little bit wrong, and I don't know the German words for what the DIN stand for, but this is a standard test as part of their classification system, with a 1400 millibar maximum being the standard maximum. And we agreed that a -30 test temperature would be sufficient to establish that it was a good low temperature grease. Again, not an Arctic grease. And the US Steel mobility test is one where we wanted to gather data to get comfortable with that 10 grams per minute minimum. And so we did, we included that in our validation testing. And so far that looks like a fine one. And with that, I'm going to hand it back over to Joe.
Chuck, I would say, why don't you hang on to that and just go through these slides. We're a time check here. We're about 12:25. So we've got about 5 minutes left on the formal hour that we had set out here. Stefan had said that we can certainly take longer for questions and answers for maybe at least another 10 minutes past that. But I recognize some people may have some other things they need to get to. So what I'd like to just point out on what we've done with these next 3 slides will be archived on the NLGI webpage, and I'll show you that in just a couple of minutes on where we keep all that. But this is just a comparison to show what Chuck has just talked about quite well, to compare the GCLB and the HPM specs with different columns for each of them, so it's easier to kind of read across or see how they compare to each other. So there's just 3 slides on that here, and maybe you could go through, just page through those. This will be captured as a separate table and put on the website. And then if you want to spend just maybe a couple of minutes on the special applications and compatibility, then we can finish up with my piece.
Yeah, and these won't take long, Joe.
Yeah.
This took a bit longer, and I apologize.
No problem.
So there are questions about specifications for specialized industries or specialized applications that need even higher performance. I kind of alluded to some of them as we went. The important message here is that the HPM grease specs are not designed to satisfy all applications or industries. Those industries and applications typically have their own specs, so this is not intended to replace them, but it's probably a good starting point for people that need those specs. They can use like HPM plus high load for the mining applications as a starting point, and then just define some more challenging limits on top of that. So grease compatibility was a question that came up quite a bit. Obviously, it can lead to some major problems. And the questions that came up are, how do we ensure compatibility if we've got a chemistry neutral specification? And we can't. Typically people will ensure compatibility by testing. They can get the data from resuppliers. And also there are these ugly looking charts that I show that are, I call them publicly available grease compatibility charts. They're all over the internet and everywhere else. That is not recommended. Please don't use those. But so how does the end user ensure that greases from different chemistries certifying to HPM will be compatible in the real world? So as I mentioned, they're chemistry neutral. So certainly they can be incompatible. I spoke of polyurea greases can meet the HPM spec. And certainly lithium complex greases can pass. They may or may not be compatible, depends on the individual greases. So if we were to include some sort of compatibility requirement in the HPM specs, it would probably lead to exclusion of some types of chemistry, and that would go directly against our chemistry neutral design principles. So there's no way to do it, and so we do not include it. We will include some advice when we roll this out with our guidance to make sure that you evaluate compatibility and don't assume that HPM greases are all compatible with one another.
All right. Want to hand it back over to me then?
If I can figure out how to do that.
Just pass me the ball and I should do it.
Yeah, I'm looking for doing that, Joe. Oh, I know how to do it.
I got it.
Back over here.
I got it.
Okay.
Yep. All righty. So certification audit process. I'll go through this kind of quickly. Again, we'll put more details on the website and I will show you that. But we are upgrading the certification renewal process. So we are working with a third party to help streamline that process. There will be samples needed to be submitted for testing as part of that certification and as part of the renewal, the yearly annual renewal. You will be required also to submit data with those submissions. So data and samples, which is more of an upgrade from what we do today. So just so you're aware of that. Again, we do not have information today on pricing. That is almost finished, and that does need to be a final approval from the board. So hopefully by the end of this month, I'm thinking we should have that out to everybody. But this whole process, we're fine-tuning it, but just big picture, it will be a little bit more detailed than you may have been used to if you've gotten GCLB in the past. Trademark timeline. So we have the trademark, the new certification marks that you've seen here. That has started this month, and essentially will be up to the full trademark registration approval by the fall of next year. But in January 2021, companies can start using this mark on their products as long as they've gotten approval through the certification process from us. The logos, these are the actual logos with the tags. So the HPM core, if you're just doing the core specification, and then each of the enhanced performance tags. We do have a trademark for the high temperature, even though we are not rolling out the high temperature approval yet. So that is on here. And then this would show you how they would look if you have combinations. So you could have HPM plus high load plus low temperature, or plus high load and water resistance. So these combinations are possible, and we have trademarked these marks to make sure that those are captured. Talked about the process. We are doing it globally and in the areas where it makes the most sense for us, and we will expand that if necessary, but these make the most sense to start with here. All right, so what can you start doing today? You can visit the nlgi.org website. You will see this with a banner at the top. So this is one of 3 or 4 rotating items on the banner. So you can click on the banner for HPM and get more details. Or you can go through the tabs through technical resources, and underneath that is certifications and then HPM. So technical resources is on our top here, come down to certifications, and then across to the HPM grease certification. If you get there by either of those 2 methods, this is what you'll see. You will see 6 boxes at this point. We may add boxes here as we get more details, as we get more things to put in here. But just to kind of highlight what is in here now, what we talked about today with Chuck's, with the HPM details, the specification details are captured there. Historical information, governance timeline, articles that we may have been published in the past, press releases, etc. And then webinars, so the webinar recording from June, from the webinar, if you were part of that, or if you missed it, you can capture that, or at the HPM panel discussion, and I believe we will have a link for this today's discussion as well. So you can start formulating products today to meet the spec details, as we've talked about, and then you will follow the instructions on how to apply for the mark beginning fall. As I said, hopefully by the end of this month, but in the very near future, this tab here will contain those details, the certification application process, the actual how to go through the paperwork piece of it. So please stay tuned for detailed announcements on that, and we will bring those to you. If you want to get communications from NLGI, you want to be part of those email blasts, you want to be notified when we have more information along those lines, please just contact us at nlgi@nlgi.org. That's you'll get your name added to the distribution. We don't want to, target you if you don't want to be in that loop, but please let us know if you do want to be in the loop. We'll add you to it. And then just a quick piece on going forward from here. So we're going to continue working on high temperature, long life categories. Those are the 2 that were kind of identified through this process, and it may be that those are 2 separate categories. And just quickly jump ahead because there was a question on the Q&A piece about this, so while I'm here. That high temperature piece really is kind of, the high temperature one is the intent right now is to work on a new high temperature rig, a bearing rig that would be built for this purpose. So that's why it's going to probably take closer to 5 years than 2. The question specifically asked about the FE9, and I think the FE9 has been recognized to be too expensive to buy on an individual use and difficult to get testing as a contract test lab. So that's the reason for trying to develop our own high temperature bearing rig test, and that is the plan at this point. Now, long life could be a different category, not focused so much on high temperature, maybe closer to electric motor bearing greases, those kinds of categories. But that's going to be further discussion. So part of what we're talking about here is working on reproducibility issues, things like fretting wear, things like the high temperature rig currently in place, the D3527. Working on those with ASTM and NLGI and trying to get those issues ironed out. This will be a living document. We don't want to wait another 30 years before we put the next spec out or make changes to it. We are not going to make changes, though, every 6 months especially to current specifications. But if there are good reasons to change or add on to or enhance, then we will discuss that and do it as necessary. And then finally, just this requires a lot of active involvement from the NLGI membership. So again, there were many people involved in this entire process over the last 1.5 years and even over the last 5 years, and the discussions that led up to it and the work that's taken place over the last year. So I would encourage you, if you have a passion around it or if you have an interest in it, to become involved. to help us, keep this going and work on the next generations of specifications and help work on the test issues, et cetera. And that's all I have here then. And I know we are about 6 minutes over at this time, so thank you for hanging in there with us. But I think, Stefan, we can take questions now, correct?
Yeah, we can. We've got some time still. We could take some questions. As you can see, we already have quite a few in the Q&A there.
Chuck, do you have any more information on the elastomer suppliers for the rubber? I know that's one of the pieces we're still talking about, and I think we have a couple in the U.S. and maybe at least one in Europe.
There's one, I believe there's one been identified in Europe. I don't know if they've worked out pricing and availability very well. We're trying to find at least one additional supplier here in the US, and there's a whole list of them that they're reaching out to. So there's a separate, smaller task force within the steering committee, and actually including folks outside the steering committee, trying to get these issues resolved. And again, I'm not the expert in this area, but yeah, the answer is yes. I think we've got one right now.
And I think the nice thing is that the ISO specification for that NBR rubber allows anybody access to be able to make that because essentially we have the recipe. So
right.
That's a good thing. So was there any end use or application in particular that drove the decision to add the additional specification types of high load, corrosion, et cetera? I would say that more arose out of the conversations that Chuck talked about with the stakeholders, with the end users, with marketers, that these were kind of the areas that were of most interest. Not to say they were the only ones, but the areas that they talked about, everywhere from mining to steel mills to just general industrial usage, there's these kind of high load, corrosion, water resistance, low temperature came up as kind of the reoccurring themes, I'd say, that seemed the ones to spend the most time on now. But certainly things like high temperature and long life that I think have utility and people are still interested in, but we're going to take some more time. Chuck, on the 100K penetration, can you please confirm if limits are percent or points?
The limits are points. They were percent in an earlier iteration, and we settled on plus or minus 30 points, one grade.
And then we say long life is years away. Has there been a discussion regarding using the FAG FE9? And what are the arguments against? I mean, so one of the main arguments is availability and price, that the unit itself is very expensive and the availability currently is pretty tough. Also, it's not that great in terms of reproducibility, repeatability. So those are the arguments that I've heard against it to this point, and that's one of the reasons I think we would like to have our own new test specifically for this use. How can we obtain a copy of the slides? These will be on the NLGI website shortly after this. If not today, then I would hope this week at least.
Plus, I believe Stefan said he's sending this out to everyone that's on the.
Okay. All right. Good. Will HPM? Go ahead.
Will HPM cover specifications for high temp grease just like low temp applications? I would say yes, but not necessarily. What we're finding when we looked at the issue of polyurea greases is that some polyurea greases that are excellent for high temperature or long life may not typically meet the HPM core spec. So what we may end up with for high temperature and or long life is a separate spec, maybe that builds on part of the HPM spec, but not all of it. So that's to be determined.
Exactly. Yeah, and that's kind of those are people within the steering committee. That this is not just, again, me and Chuck making decisions. Oh yeah, we're going to do this. It's a pretty intense discussion sometimes, and that group meets regularly to talk about these issues.
I'm looking at this question.
The last one's on the pricing structure being finalized. You mentioned the end of this month. Is that September, October? I meant October. Sorry about that, jumping ahead. And also interested in the progress of the NLGI U.S. Steel Mobility Guidelines. Any expectation on the availability of that document? Chuck, do you know timing on that?
I can say that that's kind of next up on my plate to get that moving. And I would say, I would hope that by the end of October, we should be able to have, at that point, it may not be an approved NLGI method, but I need to have something I will have something prepared for the NLGI board to vote on by the end of this month.
Okay. Very good. I think that's all on the regular Q&A. Oh, can a future grease meet all of the requirements from GCLB, HPM, plus all 4 subcategories? And I will say, without any hesitation, of course, but it's going to require somebody to actually formulate a grease that does that. I don't see why you could not, in theory, do it, but that's a technical challenge and probably a market challenge. Is something like that useful to the market? Is it useful and makes sense from a a cost of formulation or whatever aspect? So yeah, is it technically achievable? I would say if it isn't today, then at some point it should be, as we continue to evolve chemistries and grease thickener structures and additives. But there's no reason from an administrative side of things that we wouldn't allow that. So that's my best answer. Anything else to add to that, Chuck?
No, in fact, I can't even see that question.
I came up under the chat.
Oh, okay.
Yep. That's all we've got then altogether. Anything else to add, Chuck?
No, I think I overshot my time limit anyway, so I'm not adding to make people stay.
I think we both did. I took the first 25 minutes from you, so hey. Yeah, we figured we didn't have that many slides to cover, but obviously we had a lot to talk about. So we appreciate everybody's interest and everybody signing in today. Again, there's a lot more information out on the NLGI website. So please go take a look there, and there'll continue to be information out there, and you can always contact Chuck or myself at the emails shown here. Or at contact NLGI for anything regarding this or other NLGI type questions are going to be at nlgi@nlgi.org. So I would say thank you all for your patience, for sticking around this long, and for your interest.
Thank you very much, folks.
Yeah, Joe, Chuck, thank you for spending your time as well. And everyone, we will be getting this recording as well as their Chuck and Joe's contact information in the slides in my email tomorrow. So thank you again and have a great rest of your day.
Great. Thanks, Stefan.
Thank you.